Let us continue chemical equilibrium sums. Let us see the sum. We'll take for gaseous reaction. For gaseous reaction, A plus B gives C. A plus B gives C. The equilibrium concentration of A and B at a temperature of 15 molar. At a temperature of 15 molar. When volume is doubled, the reaction has equilibrium concentration of A as 10 liter, A as 10 molar. Calculate first subdivision Kc, second subdivision concentration of C in original equilibrium. Concentration of C in original equilibrium. Concentration of C in original equilibrium we have to find. Okay. Now we will see we will take the given equation, that is A plus B gives C. A plus B gives C. Now equilibrium concentration of A and B are 15 molar. Okay, at equilibrium concentration of A is 15 molar, concentration of B is 15 molar. Okay, at equilibrium concentration of A is 15 molar, concentration of B is 15 molar. Okay, when volume is doubled, okay, we are doubling the volume. The reaction has equilibrium concentration of A as 10 molar. Okay, so now A plus B gives C. We are doubling the volume. On doubling the volume, the concentration becomes off. Therefore 7.5 molar. Here 7.5 molar, we can say. If concentration is x molar here, then here x by 2. A and B is there, means C also will be there, because it is at equilibrium. So at equilibrium we are doubling the volume, therefore concentration becomes off, we are saying. So it is like this, it is become. Now due to change in concentration, because of the stress, what will happen means the equilibrium will be disturbed. Equilibrium is a disturbing, means either forward or backward favors. Okay, so which will favor? Forward will favor or backward will favor? How to know it? So for which we'll see QC and KC we will take. Okay, now we will take here. This system is at equilibrium, therefore Kc is equal to concentration of C. Denominator will be left side terms, A concentration into B concentration. C concentration is X, A concentration is 15 molar, B concentration is 15 molar, we will get Kc. Now we have given the stress. Due to stress, we are getting Qc. Qc is how much we will see. Concentration of C is X by 2, concentration of A is 15 by 2, concentration of B is 15 by 2. Therefore, we will get X into 2 by 15 into 15. Okay. So, now see the QC value. How the QC value is there when compared to Kc. Okay. So, QC is greater than Kc. QC is greater than Kc in the sense backward favors. Okay. So, we can say here backward favors. We can say backward favors. Therefore, a system attains a new equilibrium. After some time, system attains a new equilibrium. Therefore, A will be formed to some extent. Therefore, 7.5 plus X. B will be formed to some extent. That means how much A is formed, that much B is formed. C will be disappeared so much. How much disappeared in the sense here we have given X, here also we have given X, in the sense we will get confusion. So that we will change this term, we will change this term. We are saying suppose Y we are taking. Here what will happen means X by 2 we have taken, Y is disappearing. Backward is favoring in the sense C will disappear. So C is disappearing, how much means Y. Therefore A is formed Y, B is formed Y. It is new equilibrium. System is at new equilibrium now. Okay. Now what we have to find in the sense we have to find this. For this we will take Kc. For this Kc is equal to concentration of C, X by 2 minus Y, and the concentration of A 7.5 plus Y, concentration of B, that is 7.5 plus Y. Okay, concentration of B. We got Kc. Here we got Kc. Now this Kc we got. Okay. Next point they have given. After doubling the volume, the equilibrium concentration of A becomes 10 molar. Okay. In the new equilibrium, concentration of A is how much means 10 molar, yes. Therefore 7.5 plus Y is equal to 10. Therefore Y is equal to 2.5 molar. Okay. So we know the Y. We know Y value, that Y value we can substitute. Then for this reaction Kc, will be equal. Therefore we will equate this. Let us substitute this one here. Okay. Therefore X by 15 into 15 is equal to this X by 2 minus Y is 2.5, will substitute here 10 into 10. Okay. So by solving this we can get X. This X is called concentration of C in the old equilibrium. That means before giving stress, before doubling the volume. Concentration of C in the old equilibrium, we can say that is how much in the sense 45 molar. Okay. So we got what in the sense concentration of C we got in the old equilibrium, in the first equilibrium. In the first equilibrium, what is the concentration of C? We got it. Then we have to find the Kc value. We have to find, for finding Kc is equal to, we can say, concentration of C in the first, in this one we will substitute concentration of C, we will substitute, that is 45 molar. Then concentration of A we know, concentration of B we know. By solving this we are getting a Kc value, that is how much in the sense 0.2. Okay, we got Kc for this sum. Let us go to next sum. Prove alpha is equal to square root of Kp by P plus Kp. For PCl5 gives PCl3 plus Cl2, where alpha is degree of dissociation, degree of dissociation, at temperature T, when equilibrium constant is Kp. Okay. So how to prove this one, we will see. Now we will take the given equation. The given equation is a dissociation of PCl5. PCl5 dissociates to give PCl3 plus Cl2. PCl5 on dissociation gives PCl3 and Cl2. Now they are asking alpha, degree of dissociation of PCl5 they are asking. Therefore we will take initially PCl5, 1 mole will take. If we take 1 mole, dissociated is alpha, we can say. Sir. So how much dissociating? How much dissociating in the sense 1 minus alpha moles dissociate. So how much present at equilibrium? At equilibrium, how much present means so dissociating will take alpha. Dissociating alpha moles will take. So how much present at equilibrium means 1 minus alpha moles present. PCl3 formed alpha moles, Cl2 forms alpha moles. Okay. Now we have to find Kp. Okay. Kp relation will write Kp is equal to partial pressure of PCl3, partial pressure of Cl2. That is right side term in the numerator we have written. Left side term we are writing in the denominator partial pressure of PCl5. Now partial pressure we can write it as mole fraction of PCl3 into total pressure. Partial pressure of Cl2 will write mole fraction of Cl2 into total pressure by partial pressure of PCl5 will write it as mole fraction of PCl5 into total pressure. So common things we are cancelling. Therefore Kp is equal to mole fraction of PCl3 will write it as number of moles of PCl3 by total number of moles into total pressure. Mole fraction of Cl2, we will write number of moles of Cl2 by total number of moles. Mole fraction of PCl5 will write it as number of moles of PCl5 by total number of moles. Okay. This is equal to number of moles of PCl3, number of moles of Cl2 by number of moles of PCl5 into total number of moles. So Kp is equal to what we can say in the sense number of moles of PCl3 we will write it as alpha. This total pressure is there, that total pressure term we will write alpha, we will write. Then number of moles of Cl2 alpha, total pressure we have written. Number of moles of PCl5 1 minus alpha, total number of moles. This n is called total number of moles. Total number of moles is how much in the sense 1 plus alpha. Okay. So we have substituted this. Then we can write a Kp. Kp is equal to alpha square by 1 square alpha square. 1 square minus alpha square. Like this we can write into P. Like this we got. Next thing like this we got it. Next one we will simplify this one. We will get what in the sense alpha we will get that alpha is equal to how much in the sense alpha is equal to square root of Kp by P plus Kp we will get. Okay. This if we rewrite we will get alpha value, we will get this much. Let us go to next sum. The degree of dissociation is 0.4 at 400 Kelvin and 1 atmosphere at 400 Kelvin and 1 atmosphere for the gaseous reaction reaction PCl5 gives PCl3 plus Cl2. Assuming ideal behavior, assuming ideal behavior of all the gases, calculate the density of equilibrium mixture. Calculate the density of equilibrium mixture. Calculate the density of equilibrium mixture at 400 Kelvin. And 1 atmosphere. At 400 Kelvin and 1 atmosphere. Okay. Here, given equation we will take. The given equation is PCl5 gives PCl3 plus Cl2. Okay. What is given in the sense degree of dissociation is given. Degree of dissociation is given here. Okay. Degree of dissociation alpha is how much in the sense 0.4 is given. Okay. So how much we have taken initially? How much we have taken initially, we do not know, because here initially which we have to take also we do not know. But here given degree of dissociation given. Degree of dissociation in the sense that is no doubt PCl5. Degree of dissociation in the sense that is PCl5 dissociation. Okay. Because the rest of the things do not decompose. Okay. That means degree of dissociation is given for PCl5. Okay. Initially what we are taking, whether we are taking PCl5 or all together, we do not know. That means initially one possibility we can take PCl5 alone. Another possibility we can take PCl5, PCl3, Cl2. Everything also we can take. Or by leaving one, we can take rest of the two. Like this also we can take. Regarding that, no data is given. So we will assume that we are taking PCl5. Okay. Because we do not know which we have to take. So we are assuming that we are taking only PCl5 initially. Okay. How much PCl5 we have to take? That is also not given. How much PCl5 we have to take? That is also not given. No clue. So we will assume one more. We will assume one more. Okay. So we are taking the assumption that initially we are taking PCl5 and PCl5 we are taking 1 mole. We are taking like that assumption we are taking. Okay. Then we can say at equilibrium how much PCl5 will be there in the sense 0.6 mole will be there. 0.6 mole will be there. How much PCl3 means 0.4. How much Cl2 means 0.4. Okay. Now we will proceed the problem by assuming PCl5 as 1 mole. Then we will see other possibilities also. What are the other possibilities we have discussed? That possibilities also we have to discuss here. PCl5, why can't we take more than 1 mole? And that possibilities also we will see. We will check. Sorry. So we got equilibrium number of moles we got. Now what we want in the sense density of equilibrium mixture we want. We want density of equilibrium mixture. Sir, density of equilibrium mixture we want what is given in the sense temperature is given, pressure is given, number of moles at equilibrium we know. Okay. So for density of equilibrium mixture we want. For that, what are the other data known in the sense temperature at equilibrium, pressure at equilibrium, number of moles at equilibrium we know. Using this density of equilibrium mixture, we can find by the help of what? By the help of which equation? Ideal gas equation. Okay. So by the help of ideal gas equation, we can find. So here another assumption is what? All the gases are ideal gases. Okay. How do we say all are gases? Because they said gaseous reaction. Gaseous reaction they said. Therefore, we have taken another assumption, ideal gas equation, that is PV is equal to nRT. We can say this we will rewrite. We can get P is equal to d RT by gram molecular mass. We can get. Okay, sir. P is called what? Pressure. For everything we will take for equilibrium mixture. Therefore, P is called pressure of equilibrium mixture. We will say D is called density of equilibrium mixture. Then R is constant. T is called temperature at equilibrium. Then GMM is called a gram molecular mass of equilibrium mixture. Gram molecular mass of equilibrium mixture. Like this we will take. Everything we will take it for equilibrium mixture. Now we will substitute. Pressure of equilibrium mixture, that is known. That is how much in the sense 1 atmosphere, that we will substitute. Density of equilibrium mixture we have to find. Density of equilibrium mixture we have to find. Then capital R. Capital R is called universal gas constant. That is how much in the sense 0.0821 liter atmosphere per Kelvin per mole. Okay. Then temperature of equilibrium mixture, that is how much in the sense 400 Kelvin. Temperature of equilibrium mixture 400 Kelvin by gram molecular mass of equilibrium mixture we have to substitute. On substituting gram molecular mass of equilibrium mixture, we can find the density of equilibrium mixture. We can find it. Sir, how to get gram molecular mass of equilibrium mixture, that we will see. Okay. Here what we have taken means 1 mole of PCl5 we have taken initially. Okay. 1 mole of PCl5 we have taken initially in the sense that mass do we know or not? You think it. 1 mole of PCl5 we have taken. That mass do we know? Okay. For that 1 mole of PCl5 we have taken initially. Okay, that we will consider. So 1 mole of PCl5, 1 mole of PCl5 mass we know because phosphorus atomic mass 31, 5 times chlorine is there. Chlorine atomic mass 35.5. This on simplification we are getting a 208.5. Okay, so 1 mole of PCl5 weighs 208.5 gram. Okay, so 1 mole of PCl5 mass is how much in the sense 208.5 gram. Okay, now we will take at equilibrium. At equilibrium, what is there? 0.6 moles of PCl5 is there, 0.4 moles of PCl3 and zero point 0.4 moles of Cl2. Therefore, total is how much in the sense 1.4 moles at equilibrium. That means 1.4 moles of equilibrium mixture. 1.4 moles of equilibrium mixture weighs how much? Do we know this? Initially, which we have taken? 1 mole of PCl5 we have taken. We know this mass. Initially, we took 1 mole of PCl5. We know this mass. That mass is we got is 208.5. Now at equilibrium, so and so is there. PCl5, PCl3, Cl2 is there. What is the mass of equilibrium mixture? What is the mass of equilibrium mixture? Is it given? Mass of equilibrium mixture, is it given or we have to find? That means what we can say means what is the mass initially? That is the mass of equilibrium mixture. Initial mass is equal to mass of equilibrium mixture. How do we say? Law of conservation of mass. Mass remains constant. Therefore, initial mass is equal to mass of equilibrium mixture. Therefore, initial mass is what? 1 mole of PCl5. That mass is equal to mass of equilibrium mixture means 1.4 moles of equilibrium mixture. Okay. So 1.4 moles of equilibrium mixture, that mass is how much in the sense so and so we can say. So, 1.4 moles of equilibrium mixture weighs 208.5 gram. Okay. 1.4 moles of equilibrium mixture weighs 208.5 gram. So, what is the mass initial? That is the mass of equilibrium mixture. In that there is no doubt. Okay. So, 1.4 moles of equilibrium mixture weighs 208.5 gram. Therefore, 1 mole of equilibrium mixture, 1 mole of equilibrium mixture weighs, 1 mole of equilibrium mixture weighs how much? Weighs how much we have to see? That is equal to 208.5 by 1.4. It is a 1 mole of equilibrium mixture. Okay, so 1 mole of equilibrium mixture weighs this much gram. This is called a gram molecular mass of equilibrium mixture. It is called gram molecular mass of equilibrium mixture. Okay, so that gram molecular mass of equilibrium mixture is this much. Why we are saying this is gram molecular mass of equilibrium mixture? This is 1 mole of equilibrium mixture weighs this much. Okay, 1 mole of equilibrium mixture, 1 mole of equilibrium mixture weighs this much. Therefore, it is called gram molecular mass of equilibrium mixture. Okay, gram molecular mass of equilibrium mixture. We can say that we will substitute here. So that is how much in the sense 208.5 by 1.4 gram. Okay, gram per mole. So gram molecular mass of equilibrium mixture we have substituted. So we are getting from this, with this on simplification, we are getting density of equilibrium mixture we will get. So density of equilibrium mixture is how much in the sense 4.53 gram per liter. Okay, so now we have taken some of certain assumptions. Based on assumptions, we have found we got the value. Okay. Now what are the assumptions we have taken? We'll see. Initially, we took 1 mole of PCl5. Why can't we take unknown moles of PCl5? That is also there, no? We took 1 mole of PCl5 and we proceeded, we got the answer. If we take unknown moles of PCl5, can we get the answer? That we will check. Okay, sir. Now, suppose we are taking X moles of PCl5. If we take X moles of PCl5, how much will be dissociated? How much will be dissociated in the sense zero point 0.4 into X moles of PCl5 will be dissociated. Okay, so that we will see like this. We'll see in the next page. You will see. So PCl5 gives PCl3 plus Cl2. Initially, we will take Let us take initially x moles. This then how much will dissociate in the sense alpha into x. Alpha into x. Alpha is given 0.4. Alpha is given 0.4. Therefore, we will take a 0.4 x. We will take this much will dissociate. Okay. If we take initially 1 mole, then dissociation will be alpha. If we take x moles, then dissociation will be alpha into x. Therefore, at equilibrium, how much will be there in the sense x into 1 minus 0.4. Okay, this much will be there. PCl3 will be 0.4x, Cl2 will be 0.4x. Okay, like this we are taking. Now, so initially we have taken x moles of PCl5 in the sense what is the initial mass here? X moles of PCl5. So multiply this with x, multiply this with x, then multiply this also with x, correct? Then multiply this with x, this also multiply with x, then here x, here x will get cancelled. Therefore, 1 mole of equilibrium mixture again 208.5 by 1.4. So, in the density of equilibrium mixture, there is no change. Density of equilibrium, this gram molecular mass of equilibrium mixture, no change. Therefore, density of equilibrium mixture also no change. Therefore, initially PCl5 we can take 1 mole, you can take, otherwise x moles also we can take. Sir, initial number of moles of PCl5, whatever the value we want, we can take. That assumption is okay. Another one point also, what another point means, initially we have to take only PCl5 or some other also. That possibility also we have discussed. Okay, initially we have to take PCl5 alone we have to take, or some other also we have to take. That is also there. Okay, so initially what we have to take? So suppose we are taking PCl5 gives PCl3 plus Cl2. Initially I am taking A moles of PCl5, B moles of PCl3 and C moles of Cl2 I am taking. How much, what is the degree of dissociation? 0.4, therefore 0.4A. So how much remaining means 0.6A. PCl3 how much means B plus 0.4A. Cl2 how much means C plus 0.4A. Now, here if you see how many unknown terms are there, means B and C also is there. If B and C also is there, then we can say one thing we can say, that means here that means gram molecular mass of PCl5, PCl3 gram molecular mass into this, gram molecular mass of this into this. Okay, that value we will substitute. Okay, we will substitute and we'll see. Therefore, initial mass is how much in the sense PCl5 is A moles, PCl5 molecular mass is 208.5 into A moles, it is PCl5. PCl3 how much in the sense 31 is the atomic mass of phosphorus, chlorine 3 into 35.5, that is B moles, and Cl2 is 71 C moles. Okay, this is initial mass. Initial mass is this much. Initial mass is this much. Okay, at equilibrium how much will be there? At equilibrium what and all is there means 0.6 A moles, 0.6 A moles of PCl5 plus B plus 0.4 A moles of PCl3 plus C plus 0.4 A moles of Cl2 is there. This total moles mass is how much in the sense this 208.5 A plus this 31 plus 3 into 35.5 B plus 71 C grams. Okay, this many grams. So and so moles at equilibrium weighs this much. Therefore, 1 mole of equilibrium mixture, 1 mole of equilibrium mixture weighs how much? Can we simplify? We cannot. We cannot simplify this one. Therefore, we cannot simplify this one in the sense we do not know gram molecular mass of equilibrium mixture. Equilibrium mixture gram molecular mass we do not know. We do not know in the sense we cannot find a density of equilibrium mixture. Therefore, we can't take so and so assumption. We can't take so and so. We can't take initially like this. That means only one possibility. What means initially we have to take only PCl5. That's all. So in this sum, Initially, what we have to do in the sense, initially we can take only PCl5. We cannot take PCl3 and Cl2 also. Only PCl5 if we take and proceed, we will get the answer. Okay. Let us go to next sum. At 473 Kelvin, partially dissociated vapors of PCl5, partially dissociated vapors of PCl5, partially dissociated vapors of PCl5 are 62 times as heavy as hydrogen. Okay. Calculate degree of dissociation of PCl5. Degree of dissociation of PCl5 we have to find. Okay. So here what is the given data? See, at 473 Kelvin, partially dissociated vapors of PCl5. Partially dissociated vapors of PCl5 are 62 times as heavy as hydrogen, like this given. Sir. So here that means initially what shall we take? In order to get this, in order to get partially dissociated vapors of PCl5 in the sense, initially we have to take PCl5. That is one assumption. Okay. So initially we have to take PCl5. Okay. We have taken PCl5. That on dissociation gives PCl3 gas plus Cl2 gas. So initially we'll take how many moles means suppose x moles of PCl5 will take. How much dissociating in the sense some A moles dissociating. So at equilibrium, how much is there means x minus A moles is there, PCl3 A moles is there, Cl2 A moles is there. So here partially dissociated vapors of PCl5 means we have to consider at equilibrium. So at equilibrium, that means equilibrium mixture mass is equal to 62 times as heavy as hydrogen. Hydrogen is how much? 2. Hydrogen molecular mass is 2. As heavy as hydrogen in the sense, we have substituted 2. This 2 means 1 mole of hydrogen only, no? This 2 means 1 mole of hydrogen only, no? That means molecular mass of hydrogen only we have substituted, no? We have substituted molecular mass of hydrogen, sir. Therefore, we will do some correction here. 62 times as heavy as hydrogen in the sense mass of hydrogen. Like this, we will write it. 62 times as heavy as hydrogen in the sense molecular mass of hydrogen we have substituted here. Okay. So equilibrium mixture is having mass this much. Sir, okay. Now equilibrium mixture mass is given like this. Okay. Now, if I take mass of hydrogen as a molecular mass of hydrogen, if I take, then I will write 2 into here. Then I can say this is this shall I take 1 mole of equilibrium mixture? Shall I take this is as 1 mole of equilibrium mixture? So 1 mole of equilibrium mixture is this much. If I take, it is called a gram molecular mass of equilibrium mixture, I can say. If I take in the place of mass of hydrogen, molecular mass of hydrogen, if I take, that means I am taking 1 mole of hydrogen. That is the meaning. 1 mole of hydrogen I am taking in the sense 1 mole of equilibrium mixture I can take here. Then 1 mole of equilibrium mixture, then this much will come. Okay, gram molecular mass of equilibrium mixture. That is the meaning. 1 mole of equilibrium mixture. That is the meaning like this. Sorry, okay. Here we will see this is x moles of PCl5 means this mass is equal to how much means 208.5 into x gram. Okay. Therefore, this equilibrium mixture how many moles means PCl5x minus A, PCl3A, Cl2A. So total moles is how much means x plus A. So x plus A moles of equilibrium mixture weighs how much in the sense 208.5 x grams. Okay, initial mass is how much? That is the mass at equilibrium. Initial mass is how much? That is the mass of equilibrium mixture. Correct? So x plus A moles of equilibrium mixture mass is this much. Therefore, 1 mole of equilibrium mixture, 1 mole of equilibrium mixture mass is how much? That is equal to 208.5 x by x plus A, okay, this much gram we can say. This is equal to how much in the sense this much 62 into 2. Now we have to consider that here we can say that 1 mole of equilibrium mixture mass is this much in the sense that is equal to 62 plus 2, 62 into 2 we can say this many gram. This is 1 mole of equilibrium mixture mass is this much. Already we said 1 mole of equilibrium mixture mass is this much. Therefore, we have substituted like this. Now, we can find A in terms of x we can find. A in terms of x we can find here. Okay. A in terms of x we can find. Now we want degree of dissociation. Degree of dissociation is how much dissociated by initial. How much PCl5 dissociated by initial moles of PCl5. We know A, that A in terms of x we are substituting, x is getting cancelled. Therefore, we can get alpha. So we are getting alpha. Alpha is how much in the sense 68.6815. Okay, sir. Suppose we are getting confusion. Then we will do this sum in another manner. We will do it. Okay. Now initially we will take PCl5. How much means correctly exactly 1 mole will take. 1 mole of PCl5 will take. If we take 1 mole of PCl5 here alpha we can say, degree of dissociation we can say alpha. Then x will not be there, that's all. Okay. So then in that way also we can proceed. Okay. So here we are taking PCl5 x moles, we are taking x moles mass is how much means this molecular mass 208.5 into x, that is the mass of PCl5. How much dissociating means A moles dissociating. So how much PCl5 remaining means x minus A moles remaining. How much PCl3 formed in the sense A moles of PCl3 will be formed, then A moles of Cl2 will be formed. What is the total moles at equilibrium? What is the total moles at equilibrium? This one plus this one plus this one. Therefore, x plus A moles. So total moles at equilibrium is x plus A. That mass is equal to initial mass. That mass is equal to initial mass, that is equal to 208.5 x gram. So 1 mole of equilibrium mixture mass is how much? That is this 208.5 x by x plus A we can say. Here already they have given one point here. Partially dissociated vapors of PCl5. What does it mean? PCl5 is dissociated. Okay. PCl5 dissociated means in that dissociated vapors, PCl5 will be there, some amount of PCl5 will be there because partially dissociated. PCl5 completely not dissociated. So some amount of PCl5 will be there, some amount of PCl3, some amount of Cl2. This we have to take at which condition? At equilibrium condition we have to take or not at equilibrium condition. So one assumption is equilibrium condition. One assumption is equilibrium condition. Okay. So partially dissociated vapors of PCl5 means one assumption is what? Equilibrium condition. So we are considering equilibrium condition. Therefore, equilibrium mixture is having mass how many times? Means 62 times as heavy as mass of hydrogen. Mass of hydrogen, I will take it as 1 mole of hydrogen mass. That means molecular mass of hydrogen I am taking. If I take mass of hydrogen as 1 mole of hydrogen, then molecular mass of hydrogen I am substituting. If you take this is as 1 mole, if you take mass of hydrogen in that place 1 mole, if you take this equilibrium mixture also we have to take 1 mole, no? Isn't it? Here mass of hydrogen place you are taking 1 mole in the sense equilibrium mixture also we have to take 1 mole. Therefore 1 mole of equilibrium mixture is this much. Okay. Here we know 1 mole of equilibrium mixture is this much. Here we know 1 mole of equilibrium mixture is this much. Both we are equating. Therefore